Hi everybody. In this particular video, we'll be studying the bitwise operators of the C programming language. So, to understand bitwise operators, take example of the expression 13 plus 37 in which this plus symbol is the operator. Now what happens is the plus symbol acts on entire 13 and 37. It acts on 13 and 37 as it is. But instead of plus, if this is a bitwise operator, look at the word bitwise, then what will happen is that the bitwise operator will act on bits of operands. Now, the question is, what is the meaning of bits? So, in other words, the bitwise operator will act on binary equivalent of the operands. So, now the question is, how to convert operands to binary or bits? So for that, let's take an example of 37. By the way, 37 is a number in decimal format. In other words, it is to the base 10. We need to convert it into binary format, which means we need to convert 37 to ones and zeros, that means to the base 2. To convert 37 to base 2, all we need to do is continuously divide 37 by 2. So let's see. So 2 into 18 is 36, remainder 1. 2 nines are 18, remainder 0. 2 fours are 8, remainder 1. 2 twos are 4, remainder 0. 2 ones are 2, remainder 0. 2 zeros are 0, remainder 1. So now what you do is you take all these remainders in the reverse order. When you take them in the reverse order, you get 100,101 to the base 2. So that way you convert a decimal number like 37 to a binary number. Now what I want is that you pause the video and find the binary equivalent of 13 on your own. Do that. So it is 1101 to the base 2. Now I suggest that you copy this example and you should also copy the other examples and exercise questions which I will take. Now over here we have just studied that how to convert a decimal number to binary. Now let's get started with all the bitwise operators. The first bitwise operator which we are going to study is called ones complement operator or bitwise not operator or complementation operator, which is given by a tilde of the English language. Now what exactly this operator will do? So this operator reverses the bits of its operands. What I mean is that 1 becomes 0 and 0 becomes 1. Now to understand this, let's take one exercise question which says, let's see how to read it. Find 1's complement of 37. Now if you're told to find 1's complement of 37, don't forget that this 1's complement operator is a bitwise operator. So it cannot act on 37 directly. What you need to do is you need to convert 37 to binary format. So 37 to the base 10 is equal to 100,101 to the base 2. Okay. So now if you want to find 1's complement of 37, that is 1's complement of 100,101, and all you do is reverse the bits. Now what happens is the answer which you have is in binary format, that is to the base 2. You may want to convert it to the decimal format because the original question was in decimal. So now we need to know what it is to the base 10. Okay. So now let's try and understand how to convert a binary number to decimal number. So for that, I wrote the binary number over here. And now what we will do is we will give it powers of 2 starting from the right hand side. So like this. So this 0, 1, 2, 3, 4, 5 which you see in red color are basically powers of 2. Now the corresponding decimal number will be 0 into 2 raised to 0, that is this, plus 1 into 2 raised to 1, that is this. Can you take a guess what will be the next one? Plus 0 into 2 raised to 2 plus 1 into 2 raised to 3 plus 1 into 2 raised to 4 plus 0 into 2 raised to 5. So if you add all this, you get 26 to the base 10. So 1's complement of 37 is equal to 26. So that was 1's complement operator for you. Now let's go to the next category of bitwise operator, that is bitwise logical operators. We have three bitwise logical operators, that is logical AND, logical OR and logical XOR, the full form being exclusive OR. Now let's see a table which shows us the working of these operators. So over here we have bit 1 and over here we have bit 2. And in the next three columns you see the result of these operations. So let's start with bitwise logical AND first. 0 and 0 will give you 0. 0 and 1 will give you 0. 1 and 0 will give you 0. 1 and 1 will give you 1. So what this means is that bitwise logical AND will give you a 1 if both the operands are 1. Now let's see how bitwise logical OR will work. So 0, 0 will give you 0. 0, 1 will give you 1. 1, 0 will give you 1. 1, 1 will give you 1. What this means is that bitwise logical OR will give you a 1 if at least one operand is 1. If both the operands are 0, it will give you 0. Now let's talk about bitwise logical XOR, also called exclusive OR. Okay, its working is quite interesting. Bitwise logical XOR gives you a 0 if both operands are same, and it gives you 1 if the two operands are different. So if you have 0, 0, answer is 0. If you have 1, 1, answer is 0. But if you have 0, 1 or 1, 0, answer is 1. Okay. Now to understand them better, let's do some exercise questions. So the first one is on bitwise AND. Now the question says, if x is equal to 37 and y is equal to 13, find x and y. So very simple. First of all, don't forget to convert 37 and 13 to binary format, because this is a bitwise operator. So it will not work on 37 and 13 directly. It will work on the bits of the operands. Now x and y is as shown. So this is x, and pay attention to one thing over here. X has 1, 2, 3, 4, 6 digits and y has only 4 digits. So what we need to do is we need to put 2 extra zeros on the left side like this. Only after putting 2 extra zeros on the left side we can do the bitwise logical AND. So now it's very simple. Start from the right side. 1, 1 gives you 1. What is this? 0. What will be this? 1. What about this? 0, 0, 0. So this is the answer. Now this is the answer in binary format. We convert it to decimal format and the answer is 5. So I can say that the final answer of x and y is 5. Okay. Now let's go to bitwise OR and we'll do almost the same exercise question for bitwise OR. X is 37, y is 13, and we are supposed to find x or y. Now, why don't you pause this video and solve this on your own? Okay, I hope you have solved this on your own. So very quickly, let's see the solution. So 37 to the binary format is this, 13 is this, and we are supposed to find x or y. So this is x and this is y. Don't forget to put 2 zeros in the beginning. Now let's do x or y. So I hope you know how it is done. 1, 1 will give you 1. 0, 0 will give you 0. 1, 1 will give you 1. 0, 1 will give you 1. 0, 0 will give you 0. 1, 0 will give you 0. So you get this as the answer in binary format. Now let's convert it to the decimal format. So what will be the power over here? It will be 0, 1, 2, 3, 4, 5. So In decimal format, it will be basically 2 raised to 0 plus 2 raised to 2 plus 2 raised to 3 plus 2 raised to 5. Don't forget one thing, if you multiply anything by 0, then the answer is 0. That is why we have not taken the terms like 2 raised to 1 and 2 raised to 4. Anyway, so x or y will be equal to 45. Let's take one exercise question on bitwise exclusive OR. Again, if x is 37, y is 13, we are supposed to find x XOR y. So by now you know you are supposed to take 37 and 13 to binary format, and now we do their XOR. So this is 37, this is 13. I hope you remember that exclusive OR gives you a 1 if the two bits are different, and it gives you a 0 if the two bits are same. So pause the video and write the answer in binary format yourself. I hope you wrote this. Convert it to decimal format. So this is power 0, 1, 2, 3, 4, 5. Okay. So it will be 2 raised to 3 plus 2 raised to 5 equal to 40. So this is the answer. So we dealt with 3 bitwise logical operators. Now let's study bitwise shift operators. Slightly difficult than the others. Now under bitwise shift operators, we have a shift left and a shift right operator. Shift left is given by 2 less than symbols and shift right is given by 2 greater than symbols. Before we do an exercise question on them, there is one important point which you should understand about the bitwise shift operators. Now what it is? Now what happens is that when you are working with shift operators, the operand should be a multiple of 16 bits. What that means is, let's say you are using a shift operator with 37. When you convert 37 to binary format, the result is of 6 bits, 100101. Now if you want to use a shift operator with 37 in binary format, then you need to add 10 extra zeros on the left side and you need to make it of 16 bits like this. So this is how 37 should look like when you use a shift operator with 37. Okay. Now this is the general format of the usage of the shift operator. That means you write the operand, you write the shift operator, and you write some number. So one example is this. To understand the shift operator better, we'll do one exercise question. So this is the question. If x equal to 37, find x left shifted by 3 bits. So that's the way you read it, x left shifted by 3 bits. So let's start with the solution. Now x is equal to 37, which is 100101. So x left shifted by 3 bits is 100101 left shifted by 3 bits. Now don't forget, you can use shift operator only with multiple of 16 bits. So add 10 extra zeros on the left side and you get this. Now let's finally understand how the left shift will work. In left shift, what will happen is the leftmost 3 bits will get erased. They will get deleted like this. So after the leftmost 3 bits get deleted, what will happen is the remaining bit pattern will shift left by 3 positions. So now there are 13 bits over here and they will shift left by 3 positions like this. So this 0 is actually this one. This 0 is actually this one. And that way the entire pattern is shifted by 3 positions. As a result, 3 positions have become vacant on the right side and it gets filled with 0. So believe it or not, the answer is ready in binary format. But there is one very important thing which you need to understand over here. Now over here we have erased 3 zeros from the left side. Now let's say they were not 0, 0, 0. Let's say they were 1, 1, 1. If they were 1, 1, 1, can you tell me what you would have added on the right side? The answer is 0, 0, 0. So actually it is very simple. no matter what you erase from the left side, you will add zeros on the right side. That's it. As I told you, the answer is ready in binary. So let's convert it to decimal format. So what you will do is you will give powers to these numbers starting from the right side. So this is power 0, 1, 2, 3, 4, 5, 6, 7, 8. So accordingly you have 2 raised to 3 plus 2 raised to 5 plus 2 raised to 8. So that is equal to 296 to the base 10. So you can say x left shifted by 3 bits is equal to 296. Now let's do one question on right shifting. If x is equal to 37, find x right shifted by 3 bits. So once again, this is x. So x right shifted by 3 bits is this, which in turn is this. Okay, now it is simple to understand. In left shift, you erase the bits from left and you add 0, 0, 0 on the right side. In right shift, you erase the bits from right and you add zeros on the left. So because it is shift by 3 bits, you will delete 3 bits on the right side. So this 101 is now erased. The entire bit pattern of 13 bits is now getting shifted to the right side by 3 positions. So this is what happens. As a result, 3 positions are vacant. Now remember, I had told you, no matter what you erase, you will always add 0, 0, 0. So although you have erased 1, 1, 1, 1, 0, 1 from here, you will add 0, 0, 0. So that's it. The answer is again ready in binary. Now, if this is 1, 0, 0, it is simple. 2 raised to 2, which is equal to 4. So 37 right shifted by 3 bits is 4. So guys, that was bitwise operator in C language for you all. Hope you have understood it. Thank you.